Today, we'll discuss IP traffic processing. IP security is executed on a packet-by-packet basis. When IP security is implemented, each outbound IP packet is processed by the IP security logic before transmission, and each inbound packet is processed by the IP security logic after reception and before passing the packet contents onto the next higher layer. For example, TCP or UDP. There will be two situations. The figure shows the main elements of IP security processing for outbound traffic. A block of data from a higher layer such as TCP is passed down to the IP layer and an IP packet is formed consisting of an IP header and an IP body. The following steps will be occur. The first one is IP security searches the SPD for a match to this packet. If no match is found, then the packet is discarded and an error message is generated. If match is found, further processing is determined by the first matching entry in the SPD. If the policy for this packet is discarded, then the packet is discarded. If the policy is bypassed, then there is no further IP security processing. The packet is forwarded to the network for transmission. If the policy is protected, then a search is made of a SAD for a matching entry. If no entry is found, then IK is invoked to create an SA with the appropriate keys and an entry is made to the SA. The matching entry in the SAD determines the processing for this packet. Either encryption or authentication or both can be performed, and either transport or tunnel mode can be used. The packet is then forwarded to the network for transmission. The figure highlights the main elements of IP security processing for inbound traffic. The following steps will be occurs in the inbound package. First one is IP security determines whether this is an unsecured IP packet or one that has ESP or edge headers or drivers by examining the IP protocol field or next header field, that is IP version 6. If the packet is unsecured, IP security searches the SPD for a match to this packet. If the first matching entry is a policy of bypass, the IP header is processed and stripped off and the packet body is delivered to the next higher layer, such as TCP. If the first matching entry has a policy of protect or discard, or if there is no matching entry, the packet will be discarded. In the third step, for a secured packet, IP security searches the SAD. If no match is found, the packet will be discarded. Otherwise, IP security applies the appropriate ESP or edge processing. Then the IP header is processed and stripped off, and the packet body is delivered to the next higher layer, such as TCP. Encapsulating security payload. This Encapsulating security payload can be used to provide confidentiality, data origin authentication, connectionless integrity, and anti-replace service, and traffic flow confidentiality. The set of services provided depends on options selected at the time of security association, establishment, and on the location of the implementation in a network topology. ESP can work with a variety of encryption and authentication algorithms, including authenticated encryption algorithms such as GCM. This figure shows the top-level formatting of ESP packet. It contains the following fields. First one is security parameter index. This is the 32-bit identifier security association. Next field is called as sequence number. This is also 32 bits. A monotonically increasing count value. This provides an anti-replay function. Next field is called as a payload, and this is a variable. This is a transport level segment or an IP packet that is protected by encryption. Next field is called as padding. The purpose of this field is to add extra bit. Pad length, it is a 8 bits, indicates the number of pad bytes immediately preceding this field. Next header, this is an 8-bit, identifies the type of the data contained in the payload data field by identifying the first header in the payload. Integrity check value, a variable length field that contains the integrity check value computed over the ESP packet minus the authentication data field. When any combined mode algorithm is applied, the algorithm itself is expected to return both decrypted plain text and a pass-fail indication for the integrity check. Two additional fields may be present in the payload that can show in this diagram. An initialization value IV or none is present if this is required by the encryption or authenticated encryption algorithm used for the ESP. If tunnel mode is being used, then the IP security implementation may add traffic flow confidentiality padding after the payload data and before the padding field as explained subsequently. Encryption and authentication algorithms. The payload data, padding, pad length, and next header fields are encrypted by the ESP service. If the algorithm used to encrypt the payload requires cryptographic synchronization data such as initialization vector, then these data may be carried explicitly at the beginning of the payload data field. The ICV field is optional. It is present only if the integrity service is selected and is provided by either a separate integrity algorithm or a combined mode algorithm that uses an ICV. Next, we will discuss padding. The padding will be serves several purposes. First one is if an encryption algorithm requires the plain text to be a multiple of some number of bytes, the padding field will be used to expand the plain text to the required length. Second purpose is if the ESP format requires that the pad length and Next, header fields the be right aligned within a 32-bit word. Equivalently, the ciphertext must be an integer multiple of 32 bits. The padding field is used to assure this alignment. Third purpose, additional padding may be added to provide partial traffic flow confidentiality by connecting the actual length to the payload. Next is anti-replay service. A replay attack is one in which an attacker obtains a copy of an authenticated packet and later transmit it to the intended destination. The receipt of duplicate authenticated IP packets may disturb service in some way or may have some other undesired consequences. So when the new SA is established, the sender initializes a sequence number counter to 0. Each time that package will be sent to this SA, the sender increments the counter and places the value in the sequence number field. Thus, the first value to be used is 1. Anti-replay is enabled. The sender must not allow the sequence number to cycle fast 2 to the power 32 minus 1 back to 0. Inbound processing proceeds as follows when a packet is received. If the received package falls within the window and is a new, the MAC is checked. If the packet is authenticated, the corresponding slot in the window is marked. Second point, if the received packet is to the right of the window and is new, the MAC is checked. If the packet is authenticated, the window is advanced so that this sequence number is the right edge of the window and the corresponding slot in the window is marked. If the received packet is to the left of the window or if the authentication fails, the packet is discarded. This is an auditable event. Thank you.